Hello, my friends. Happy to be back at YourVision.blog, and today I have two fantastic guests. It's Werner and also Matthias. And please introduce yourself. And please, Werner, start and show us what you're doing.
Well, thank you for having us, Georg. I'm Werner Paulin. I worked all my professional life in the automation industry. I love machines. For 30 years, I did various roles in always international, always close to customers. I was programming machines, was a system architect in R&D for automation suppliers. I was in business development and also did product ownership. Today or nowadays, I help industrial companies in the area of digitalization. So let's say a customer, industrial company wants to revamp their automation system or want to market a digital product, which is basically a hardware with enriched software features which bring added value. This I would say what I would call a digital product. Then I help them with strategy, market positioning and implementation of this digital product. And I'm looking forward to discussion today with Matthias from the VDMA, because I was thinking a bit about this interconnected world in the IT, and we in the machine building or industrial world, we still basically are quite fragmented. We live on islands, and I think this session is a good opportunity to talk about how can we bridge the gap to get more interconnected.
Thank you, Werner.
Thank you, Werner. Hello, Georg. Thank you for being here in your podcast, and nice to have this discussion with Werner. My name is Matthias Scharpe, and I work at VDMA in Frankfurt, Europe's largest network organization for machinery and equipment manufacturing, representing 3,500 member companies. And at VDMA, I focus on digitalization and information for industrial networks, with a focus on data ecosystems, such as Manufacturing X, and within the VDMA Software and Digitalization Association, we bring together more than 500 software vendors, a part of this 3,500 members in VDMA, that enable digitalization and interoperability for the mechanical engineering companies. Another topic I have is I lead the IT cost and benchmark at VDMA, helping companies better understanding and optimize their digital investments. And furthermore, and I think that is the topic here, I'm involved in the government-funded Manufacturing X initiative named SLMs, where we demonstrate how data space technology allow companies to collaborate securely, efficiently, and sovereignly across supply chains and to share data. And my work here at VDMA bridges the industry, the software providers, and the public initiatives, turning digital collaboration into a competitive advantage for the machinery industry of tomorrow. And I'm also looking forward to an engaging discussion and how data spaces create value for the industry. Thank you for being here.
It's really a big pleasure for me to have VDMA on stage. I remember back in my time when I was working for Liebherr, VDMA has a big name. It's very important for the machinery engineering companies.
It's very important, and I'm so happy to see that VDMA is supporting the industry, going digital faster, and for all the work you're doing here to be on top.
That's really fantastic. Thanks to have you here, Matthias.
Thank you very much.
There are so many things that traditional engineers now they are going digital, and you spoke about data spaces. What is a data space?
Yeah, very good question. But let me think in one point. Furthermore, the question for me, it's how will the industry work in the future for tomorrow? And the data spaces are only an infrastructure. And maybe the people who hear your podcast don't know exactly what are the basics. Therefore, let me start a little bit with an explanation to say in what is a starting point for the data spaces. Because when you share data, then you need data that is prepared, that could be shared in an interoperable way. And that is a situation here. And in simple terms, I will start with a digital twin. That means every machine will have a digital twin in the future. And this digital twin travels along with the product in the full life cycle, from engineering, production to commissioning and operation. And the digital twin keeps all relevant product data consistent and up to date, and is a digital model. And Manufacturing X, the data space initiatives, use this digital twin to share data for this asset. And that means for the future, the machinery industry needs a digital representation for their physical products. And therefore, they have to think in both ways, in digital ways and physical ways, and bring this together in their production to share data over a data space.
Georg, let me bring in here the perspective of a machine builder or a component supplier, because it's not about only the data space is not only used by machines, but also by industrial component suppliers. I think if you ask someone what is a machine, is this hardware or software or an automation product, they will say, it's clear, it's hardware, because it's tangible. But the hardware itself from a component or machine is not enough to install, integrate and operate this machine in a factory. Yeah? So you need digital informations, for example, like the 3D model, for example, to optimize the flow in a factory, to define working zones where people can access and not access a machine, for example, bill of material, there's the software bill of material communication interface, because a machine is never alone in a factory. It's always connected to a production chain. So in the past, these manufacturers, they had the need to offer this digital information to their customers. And they did this by their own channels. They had their own server, and while this is valid to have their own server, they also have their individual contracts. What information is shared, how much is shared, what's the government, what's the legal implications of this one. And if you are on the other side as a factory operator, it becomes quite cumbersome and maybe even unmanageable, because you have many suppliers which bring machines into your factory, and each machine has multiple different components, and it becomes very difficult to basically to run your factory at some point or to install everything. So it all takes time, and time is money, and money basically defines competitiveness basically and your profit. So some people would say, okay, we have a number one solution, basically it's the hammer for each nail, and this is a central cloud. When we from a European perspective, we have to look either east or west to find a hyperscaler. And especially, for example, if you look west, then we have the US Cloud Act, basically, which allows the government to access any data. So it's not about if they want. This is not what we Europeans want. We in Europe, we think different. We think that data has a high value, also need to be protected, but also basically shared in a controlled way. So for all participants, so not that someone has a certain advantage over the data. And that's why Europe came up with a decentralized approach. So not a central cloud, a decentralized approach. And the irony in this thing is that the internet originally is a decentralized network. Yeah? It was made to basically resist breakdowns of servers, and it comes from the DARPA area. And this is where basically the data spaces originated, to have basically, and this is what Matthias said, to have a way to communicate with each other, to exchange data, but in a secure, also legally clearly defined concept. So it's basically the tunnel for your data, and the VDMA is here, I would say, in the lead of pushing such kind of initiative.
Yes, and what I can explain here as well is that you have to decide by yourself, by your company itself, will you decide how long, which data. And therefore, this collaboration via data over the borders of the company, that is the goal which the EU is organizing, that we are able to be sovereign and not using platforms where the platform provider is the owner of the data. And this is a new concept of the EU, and the EU supports this with a lot of projects. And one of these projects is a big project for the manufacturing industry, is Manufacturing X. And this is a possibility to organize more use cases that can be used with the data space, and the companies can see if it is necessary for their personal use and is there the possibility to adopt this technology to be more efficient, to organize more use cases, and to drive business in a new modern way. And the digital twin, as to remember, is one possibility. When you prepare your data in your company, then you are able to share.
But not only the problem of sharing the data, the main problem is the willingness of sharing the data. So if you have the machine manufacturer and there is the production company, they often don't want to share their information with the machine manufacturer because they are afraid that the information will go to their competitor. Is there a solution for this?
Yes, that's a big problem. But at the end, if we work in the normal world, we share information. We share information normally. And I think we have to see what data is necessary to make the process more efficient and what is CI data, what is necessary for my company to have an USP against others. But let's have an example here. If you see the smart connected supplier network in the Netherlands, they have 500 partners and they work on different levels in supply chains. And they share information, what product is needed at one time, when will I deliver, when will I share the information. When I share informations, I'm very fast because we share here machine readable information. And not only in a PDF, we share machine readable information that the ERP system is able to understand when the order comes in, when the order is confirmed, when it is delivered, and so on. And therefore, only the relevant information is shared, not all information, only relevant information. And this information is on the paper. You get it with an envelope. But no, you get it more digitally in the application over the borders of the company. And that makes it much more efficient. Data space reports more than 20% productivity in the communication over the companies. And that makes sense.
I think to add on this topic, I had contact with many machine suppliers, and I would say the lack or the absence of a legal framework, like the data spaces will bring with them, prevented them to open the door to the machines. Because what do machines usually have? Let's do here very handsome. They have normally a remote access tool. It's a bit like, looks like a switch, looks like a modem or something in the old days. Yeah? If you're a dinosaur, the term modem, now you would call it router or edge device or something like this. But if you open this to your supplier, you have full access to everything, to the PLC, to configuration data, to live data. It's for a machine, the factory hesitates to open this because they open everything. Now, with the data spaces, you can very much define what should be shared or not. And after maybe I think you have a question, I give you a few examples because I would say sharing data is in our all interests because it will improve our overall competitive advantage and competitiveness in Europe, but I would say also globally. But I would say the absence of the legal framework prevented a little bit here the openness because it was only digital, open or completely closed.
And can you define with whom you share the data?
Yes, you can define. And this is the design of the data spaces, that you as a company are identified in the data space as legal company and you have an identity. That is the first point. Then there is a possibility to find all identified partners, and then you have digitally the possibility to ask for information and then do sign a digital contract to share this information, and you define how long you share, which data you share, and therefore the security comes from this trust, that the trust is delivered by the data space, that the people who are using this data space are trusty partners and they have an EU business wallet, that the identifier is verified And therefore, this is a possibility you have, and this is a role of the data space. And we have here in Germany, out of this project, we have Cofinity X, maybe, that is a data space provider who has this services for his partners that they have here a trust infrastructure to share this information.
And the information you share via the digital twin, it is not only shared when you buy and install the machine, also during the lifetime, you make the full lifecycle management. Is there anything more what helps? Maybe for predictive maintenance?
Yes, but keep in mind, if you sell a product, a physical product, then it comes in your company. And then you have the question, okay, how do I organize and document the status of the machine? And so on. And therefore, big companies have an asset lifecycle management. And then there's a person who adds this information by hand in the asset lifecycle management. And if I sell a machine and a digital twin together, then I have the possibility to onboard all this information automatically in this asset lifecycle management. And then I have this information completely without working by hand in the system. This is more efficient. And then it comes to your use case, predictive maintenance. If you imagine there is a customer side and he has then an issue with his service. Today, there is a situation that the technician often searches a lot of manuals, serial numbers, software versions, and spare part informations, often spread across a lot of emails and PDFs and different systems. And with the data space, the machine has the digital twin and the structure in this digital twin with all relevant informations for the situation. And it contains this like a container, and this information is then connective with via the data space, and the service technician gets secure access to the writing, and then the maintenance is much more faster, and the configuration of the repaired machine can be documented back in the digital twin, and then you have exactly the information you need, and it's very efficient documented. And this helps in this predictive maintenance use case.
Let me add here something beside the service and predictive maintenance. I would call it data-driven product management or product development. And the data space opens here something completely new, what we are currently not able to do, but from an R&D or product management perspective, it would be very interesting. And the IT basically, in the consumer world, the devices do this already without our consents or with our consents. And the examples, I would call it upstream publishing of data. So I give you an example. Let's say you are a component manufacturer for a machine. Let's say you supply servo drives. What is a servo drive? A servo drive basically controls the speed, position, torque of a motor in order to basically control a process flow in a machine. Okay, this is a box with software, and these boxes are basically configured or very precisely configured for the motor they drive, because no one wants to have a box or a servo drive which is too big or too weak. So it's customized, configured. Now, the automation supplier, as a product supplier, you will offer these configuration possibilities, and then this product are shipped. But you so I'm now the component supplier. I never know how is my product really used. I don't know it. Yeah. So the customer configures it. I help him maybe with my sales force. I help the customer to configure it, but I never know, is it running at the edge or is it always running in an area which was not defined? Obviously, what I cannot do is issue a questionnaire, send them by email, and please tell me how is your product running, because actually this is so fast. You can't, first of all, no one does it. Second, this is not the appropriate way to do. So to get, and this is anonymous data, so we as an automation supplier, I don't care what kind of product is produced or what is the secret recipe to produce this product. I want to know how is my product used. I need to be optimized, because people go always on the safe side because my configuration is not precise. So I can basically, based on data, I can optimize my product. Similar thing, maybe a bit more hands-on. Let's talk about heat pumps. Also something I experienced in the past. So heat pumps going in factories, but also in households. And maybe as a heat pump manufacturer, this can be generalized. You implement a special operating mode, something a customer can choose. But you never know, does a customer use it or do they bypass it? Do they always block it because you don't have access to the log files, for example? You have no feedback channel. And if you would have them and you don't care how the heat pump is used, you just want to know, do they actually use it the way I designed it? And what would be great for the entire value chain, for the ones who produce it, also for the one who buy it and operate this, to get a more optimized product. And this is, for example, something you can do with a data space, because you can define, I want this anonymized data item, and then it's very clear what is shared. And it's to all of our best, I would say, if we can do this.
That's fantastic. If you don't want to miss such a fantastic discussion and to get a lot of information, don't forget to ring the bell that you get informed when the next version will be online at YourVision. So, Werner, you were talking about the heat pump and to get all the information back when it is in use. Is it like you can compare it with a big brainstorming when the engineers sit together, that this is a full life cycle brainstorming with the heat pumps?
Exactly. You discuss with the heat pumps itself, because you have access to not only your 5 heat pumps you have in your lab, what you use, and it's used by all your quality engineers which know how the heat pumps are used. So you basically get the entire installed base giving you feedback how they are used. And this is then not product development which doesn't think, okay, I think we need to implement this or that. It's really data driven. You can say we implement this in our product because it will change this and this. And then you have also the business case, because you know what will happen if you change this, how people are react. And then maybe you can roll it out to a certain user group. This is, by the way, also already applicable to a user group which basically wants to always have be beta tester and so on. So you have a full data-driven soft product development. And this, to my existence, is rather new. Why? Because this is what we discussed before. No one wants to open everything uncontrolled. But if you say, I want this data because I use it as to optimize my product and it's anonymized, for example, then people tend to, I would assume, to agree more to this because it would be in their benefit also. And you can create business models. You can say, you open the data, you get the newest software, for example. You get the features with a discounted price or something like this. This is just now an example, but I would say it's for the benefit of all of us to improve our product.
And this is a very good example from Werner, because if you have this data then from your components, then you are able to sell this data to new customers, because then you have the experience that this product is in that environment. And if you create new products for that environment, you have the data out of the shop floor that you can adopt this data in your construction, and you can simulate with this data the new product features. And then you have an add-on value on your products. It's not only the product itself, it's a data, not only description and documentation. No, it is the data of the usage of the product in a special environment. And that is an added value for a lot of customers when they're using these components.
And Matthias, what is the role here of the VDMA?
Oh, yes. Thank you very much for these questions, because the VDMA is not the user of the data space. The VDMA is involved in the funded projects like Manufacturing X, and we support with our experience these projects. And on the other hand, we have the 3,500 members of the VDMA. Therefore, we have the role of communication these new ideas to our small and medium business customers, members, and bigger companies, that they are able to adopt, to understand how they can use these use cases. And you see, we have here a very interesting discussion, but at the end, there is a use case behind, and each member of the board has to decide should I invest in this new technology? What is the benefit for me? And therefore, we help them to understand the technology and to link people together and maybe bring universities on board that they are able to test and to make pilot projects to start with their partners together in this area of data spaces.
So as you can hear now, Matthias is the center role to connect everybody and everything together, that the data space will work perfectly for everybody, for the member companies, for universities, and also for the companies who use the products. Is this right, Matthias?
Yes, that's right. And I will say, not only for members of the VDMA, we support all companies out of these funded projects, and therefore reach out to me and ask me. And if you are not producing a machine, don't worry, ask me.
That's perfect. And the contact details you will find below. And please contact Matthias. That's really great. So this is really fantastic to bring them all together. But I'm from the business side. So what is the advantage for the users? So does there exist a business model for this?
That's actually the point where I come into the game. People hear about these things, about digitalization, I would say in general, and many companies are willing to go there, but they say, how do we actually approach this point? And some people actually say, I don't even see a use case. So I don't see a business case for this, because as a machine builder, they look very closely on their margin. They say, okay, what does software bring me? Or what does this digitalization bring me on the bottom line, basically, of the EBIT? And I would say my job is basically to open their eyes, if I'm allowed to say this, to see what is possible. For example, you have added customer value. This sounds easy, but for example, data-driven product development. These are things which I basically work out basically with them. So, and at the end, it's all about a market-driven portfolio strategy, because I'm not approaching a customer. The situation is not like this. They say, okay, we want this product and we need this connected to the data space or something like this. So it's typically a bit of a transition in the automation industry. So it's not about one product, it's not about only the data space, it's overall to define a portfolio which is a future proof, or which brings us into the future. And the interesting thing on this one, and this is a bit, now I'm leaving the data spaces now a bit on the side. The interesting thing, it's typically a people topic. Because what you realize is, if you take any company, you take a very big company with 5,000 people and remove these 5,000 people, take them out, take new people in, you don't have the same company anymore. So the culture, the way the DNA a company works is defined with the people. So if you want to transform into digitalization and you want to add this to your product portfolio in any kind of shape, it starts, I would say, with leadership. And this is also something, because I had the honor and the pleasure to work on these topics in the past. And this is something where I also help companies. So, because it's very clear, if we in Europe, we want to remain competitive, because we have domain knowledge, and we need to bring this domain knowledge into the new era, I would say. In the era of AI, everyone talks about AI, but it's not about LLM, it's about SLM, small language models or something, to combine them with our unique knowledge to manufacture things. And I always say, as long as we drink real milk or real water packed in bottles, we need real life machines. We cannot live on servers. We are not in the matrix, or at least as soon as I think we know we are not in the matrix. So it's all about this. And this is where basically I help them to bridge, basically to bring them along the way to the digitalization, to the data spaces and so on.
So Werner, you make the bridge between product manufacturer and the machine manufacturer to show them what they can do, what is the value of such a digital twin. That's really great. That's really fantastic if Werner gives the solutions for the product development, and also Matthias from the VDMA to motivate the companies to work on it, to use it. Below there is also a collection of very good links for dates and also for very good use cases where you can have a look what is fantastic. Could you give us a summary of this, please, Matthias?
Yes, thank you very much for this question, because data spaces are technology, and we try to explain a little bit how it works. And now the question is for the decision makers in the companies, that they understand the new technology and decide by themselves, is there an option for new products, for new services? And then they have to go to Werner and discuss this in more detail. But the question they should do by themselves, I think, is led by 3 points. I think to summarize in these 3 points, first, engineering becomes digital. We should know components and machines are not longer designed only by physical products, the future, and this digital twin travels along with the product in the full life cycle, from engineering, production to commissioning and operation. And the digital twin keeps all relevant product data consistent and up to date, and is a digital model. And Manufacturing X, the data space initiatives, use this digital twin to share data for this asset. And that means for the future, the machinery industry needs a digital representation for their physical products. And therefore, they have to think in both ways, in digital ways and physical ways, and bring this together in their production to share data over a data space. From the beginning, every machine is engineered together with its digital twin, which carries all relevant informations over the whole life cycle, from the design of the production to operation and services. That is the understanding, and I should know how I deliver my products in a digital way. And how do I organize this in parallel to my production of the physical product? First. Second, engineering becomes connect. That means the data space delivers the possibility connect once and then work with all other together, because there's a secure way to do this. Instead of changing documents or files, companies can collaborate through the data space. Standardized. And the relevant point is they can share machine-readable data flows securely between their partners, their manufacturers and suppliers. And the company has over this sharing the full control of its data. That is the second point. And I think the third point is engineering and processes becomes faster. They becomes faster. Often we heard from this China speed. That makes the question for us in Germany, how can we work faster together? And this technology helps us to work faster together with the truths of data. And this makes us more valuable, and therefore manual work, repeat data entries, and communication loops are reduced or disappeared. And engineers can focus on innovation and quality, and they create new services for their products and for their business, and the data for the using in an efficient way a very good data handling. And that means shorter lead times, lower costs, and more competitive products. And I think this is necessary for the machinery industry to lead in the global competition out of Germany. And this is what I think is a possibility how we can work tomorrow in machinery industry, digital, connected, and much more value driven. And that is enabled with the Manufacturing X projects and with the data spaces.
Thanks a lot, Matthias. Werner, do you have something to add here?
I think we in Europe, we very often look to the West and to the East. We are super impressed what kind of technology is invented there. And we sometimes forget that we have on the machine building industry an extremely profound know-how, and we have also the capabilities for digitalization. We do it differently. Also, Europe is different. Europe is a continent with many countries which are individual, which are decentralized, and this reflects, for example, the data space. And we have all the know-how. We have on AI, on digitalization, on machine building, on domain knowledge, how to produce things. The world needs physical goods. We are the ones who are able to produce them. We just need a bit more self-confidence that we are able to do this if we work together. I would say that the time of Leonardo da Vinci is gone, where everyone is a single super genius. We have to work together. And I would say the data spaces are the major element to bridge basically between these companies, machines, And I would say that's why we need to pursue such kind of thing.
Yes.
That's really fantastic. Coming together, the product development, digital twin, and the manufacturing companies. That's really great. Thanks a lot, guys. This was really fantastic, a great input. And yeah, that's the way how we will work in the future.
Thank you, Georg.
Georg, thank you for having us.
Thank you, Georg. It was a pleasure. Thank you very much.